Hello, welcome to Astronautics for Exploit. In this video, I will be going over International Astronomical Union, Interplanetary Medium, Solar System, the Sun, the planets, the primary planets, the Dwarf Planets, Trans-Neptunian Region, and Kepler's law of planetary motion. International Astronomical Union was established in 1919. And its mission was to promote and safeguard the science of astronomy in all its aspects, including research, communication, education, and development through international cooperation. Its tasks are to define fundamental astronomical and physical constants, ambiguous astronomical nomenclature, and informal discussions on the possibilities for future international large-scale facilities. Its task is also to serve as the internationally recognized authority for assigning designations to celestial bodies and survey features on them. International Astronomical Union makes recommendations based on well-established scientific facts with a broad consensus in the community concerned. Classification of solar system objects is done by IAU, and it gave criteria for a full-size planet that it must be in orbit around the Sun, it must have sufficient mass to assume hydrostatic equilibrium, a nearly round shape, and it must clear the neighborhood around its orbit. The picture to the right shows planetary session of the IAU 2006 General Assembly, which was held on August 24, 2006. Interplanetary Medium is a near vacuum that the majority of solar systems consist of. Solar wind is a continuous stream of charged particles, a plasma which is radiated by the Sun along with light into the interplanetary medium. Space weather and geomagnetic storms. Activity on the Sun's surface, for example, solar flares and coronal mass ejections, disturbs the heliosphere, thereby creating space weather and causing geomagnetic storms. Earth's magnetic field prevents its atmosphere from being stripped away by the solar wind. And due to Venus and Mars having no magnetic fields, solar wind causes their atmospheres to gradually bleed away into space. The heliosphere and planetary magnetic fields partially shield the solar system from high-energy interstellar particles, which is referred to as cosmic rays. This picture shows solar system and interplanetary medium. Solar system is a system that gravitationally binds the Sun and the objects that orbit it. The distance from Earth to the Sun is about 1 astronomical unit. Solar system is composed of a star, which is the Sun, that is the principal component. The planets, which are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. All the 8 planets have almost circular orbits that lie within a nearly flat disk, which is referred to as the ecliptic plane. The dwarf planets, for example Pluto, and others are moons, asteroids, comets, and meteoroids. Naming of solar system objects. The names of the major planets were already in common use when the IAU was formed in 1919. And the naming in 1976, the IAU lists the names of the then major planets and the Earth satellites as the major planets Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, while the Earth satellite as Moon. In 1988, IAU lists the names of the principal planets as Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. And in 2006, IAU explicitly lists the 8 planets as Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, and the Earth satellite as Moon. In 2006, IAU classified Pluto as a dwarf planet because it couldn't meet the third criteria for it to be a planet. It does not clear its neighborhood. This picture shows solar system composition. Ecliptic plane. As orbits plane around the Sun is referred to as ecliptic plane. Most large objects in orbits around the Sun lie near the Earth's ecliptic plane. Sun gravitationally dominates and contains about 99.86% of the total mass of the solar system, while 99% of the remaining mass belongs to the Sun's largest orbiting bodies, which is referred to as the giant planets. Jupiter and Saturn together comprise more than 90%. The 4 terrestrial planets, the dwarf planets, moons, asteroids, and comets, comprise less than 0.002% of the solar system's total mass. The Sun, which comprises nearly all the matter in the solar system, is composed of 98% hydrogen and helium. Jupiter and Sun, that comprise nearly all the remaining matter, are primarily composed of hydrogen and helium. The Sun is the principal and most massive component of the solar system. It is a star at the center of the solar system and is moved by the gravitational pull of the planets. It in turn releases an enormous amount of energy, and this energy is mostly radiated into space in form of electromagnetic radiation. The Sun's structure is the core, radiative zone, tachocline, convective zone, photosphere, and atmosphere. Solar calendar. The synodic rotation of Earth and its orbit around the Sun are the basis of solar calendars, and one of them is the Gregorian calendar, which is the predominant calendar still in use till today. This picture shows the glowing of the Sun. The planets. According to IAU, a planet is a celestial body that is in orbit around the Sun, that has sufficient mass to have a nearly round shape and has cleared the neighborhood around its orbit. The main classifications of the planets are terrestrial or inner planets, which are Mercury, Venus, Earth, and Mars; gas giant or outer planets, which are Jupiter and Saturn; ice giants or outer planets, which are Uranus and Neptune; and dwarf planets, which are Pluto, Eris, Haumea, and Makemake. This picture shows inner solar system, outer solar system, orbit of Sedna indicated disk, and the Oort cloud. The prominent planets are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Sun rotates counterclockwise, as shown in the picture to the right, and this is as viewed from above Earth's North Pole, while planets and most other objects obey the Sun in the same direction as the Sun is rotating. Primary planets, the terrestrial or inner planets. Terrestrial or inner planets are primarily composed of rock and metals with few unknown moons and no ring systems. All have impact craters and tectonic surface features such as rift valleys and volcanoes. They are composed largely of refractory materials, for example, the silicates, which form their crust, and mantles and metals, such as iron and nickel, which form their cores. Examples of terrestrial or inner planets are Mercury, Venus, Earth, and Mars. Venus, Earth, and Mars have atmospheres substantial enough for them to generate weather. The constituents are near-Earth asteroids, many of which cross the orbits of the inner planets. Some of them are potentially hazardous objects. Giant or outer planets are outer planets more massive than the terrestrial planets, also referred to as Jovian planets, and collectively make up to 99% of the mass known to orbit the Sun. Examples of giant or outer planets are Jupiter, Saturn, Uranus, and Neptune. Gas and ice giants. Jupiter and Saturn are two largest gas giants planets, which together are more than 400 times the mass of Earth. They are composed of hydrogen and helium gases. All four giant planets have rings, although only Saturn's ring system is easily observed from Earth. Uranus and Neptune are two outermost ice giant planets. They are far less massive, less than 20 Earth masses each. They are composed primarily of ices with high melting point. Mercury. Mercury is the closest planet to the Sun, and it is 0.4 astronomical unit from the Sun. It is the smallest planet in the solar system, and Mercury has no natural satellites. Its only known geological features are lobed ridges or roofs, and it has very tenuous atmosphere. Venus is about 0.7 AU from the Sun and close in size to Earth. Like Earth, Venus has a thick silicate mantle around an iron core. It is much drier than Earth, and its atmosphere is 90 times as dense. Venus has no natural satellites. It has substantial atmosphere, and it is the hottest planet. Venus has no magnetic field. Earth is the largest and densest of the inner planets. It has a distance of 1 astronomical unit from the Sun, and it is the only one known to have current geological activity. Earth is the only place where life is known to exist. Its liquid hydrosphere is unique among the terrestrial planets. It has one natural satellite, which is the Moon, the only large satellite of a terrestrial planet in the solar system. Mars is smaller than Earth and Venus. It has a distance of about 1.5 AU from the Sun, and it has an atmosphere of mostly carbon dioxide. Its red color comes from iron oxide in its soil. Mars has two tiny natural satellites, which are Deimos and Phobos. Jupiter is 2.5 times the mass of all the other planets. It has a distance of 5.2 AU from the Sun and is composed largely of hydrogen and helium. It has cloud bands and great red spot. Jupiter has 79 known satellites, with the four largest of them being Ganymede, Callisto, Io, and Europa. Ganymede, the largest satellite in the solar system, is larger than Mercury. Saturn has a distance of 9.5 astronomical units and extensive ring system. It has 60% of Jupiter's volume. Saturn is the only planet of the solar system that is less dense than water. The rings of Saturn are made up of small ice and rock particles. Saturn has 82 confirmed satellites, which are composed primarily of ice. Uranus has 19.2 AU and is the lightest of the outer planets and has more than 90% azimuth to the ecliptic. It has a much colder core than the other giant planets and radiates very little heat into space. Uranus has 27 known satellites, the largest ones being Titania, Oberon, Hubble, Hera, and Miranda. Neptune has 30.1 AU, which is slightly smaller than Uranus but more massive with the Earth. It radiates more internal heat, but not as much as Jupiter or Saturn. It has 14 known satellites and Triton is the largest. Triton is the only large satellite with a retrograde orbit. Neptune is accompanied in its orbit by several minor planets termed Neptune Trojans. Dwarf planets. By IAU, a dwarf planet is described as a celestial body that is in orbit around the Sun. A dwarf planet has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium, nearly round shape. It has not cleared the neighborhood around its orbit and is not a satellite that is not caught in an orbit around the planet. Examples of dwarf planets are Pluto, Ceres, Makemake, Haumea, and Eris. Dwarf planets are officially recognized by the IAU. Due to their smaller nature, dwarf planets lack the gravitational forces needed to pull in and accumulate all of the material found in their orbits. They are much smaller than the 8 major planets, and they are smaller than Earth's moon. Pluto. Pluto is a dwarf planet in the Kuiper Belt, a ring of bodies beyond the orbit of Neptune. Pluto was the first and the largest Kuiper Belt object to be discovered. IAU in 2006 reclassified Pluto as a dwarf planet because it could not clear its neighborhood. Ceres is the largest object in the main asteroid belt between the orbits of Mars and Jupiter. It is the only dwarf planet which is located in the inner solar system. And when Dawn arrived in 2015, Ceres became the first dwarf planet to receive a visit from a spacecraft. Ceres is at 940 kilometers in diameter and is the only asteroid which is large enough to be rounded by its own gravity. Makemake is a dwarf planet in the outer solar system. It was the fourth body identified as a dwarf planet and was one of the bodies that caused Pluto to lose its status as a planet. Makemake is the second farthest dwarf planet from the Sun and also the third largest dwarf planet in the solar system. Haumea is the third closest dwarf planet to the Sun and is located beyond the orbit of Neptune. It has about 1/3 the mass of Pluto. Its ellipsoid shape is believed to be the result of its rapid rotation. It's made from rock with a thick coating of ice. Haumea is the third brightest object in the Kuiper Belt after the dwarf planets Pluto and Makemake. Eris is a dwarf planet which is situated beyond Neptune on the edge of the Kuiper Belt. It is an icy rocky planet twice as far from the Sun. In size, Eris is smaller than the Moon and is about 1/5 of Earth's radius. The closest that Eris can get to the Sun in its orbit is 37 AU, and the farthest it can get is about 97 AU. Eris is the second largest known dwarf planet in the solar system and is slightly smaller than Pluto, but it is more massive than Pluto. It is the most massive of the known planets. Eris has one known moon, which is referred to as Dysnomia. Trans-Neptunian region lies beyond the orbit of Neptune with the donut-shaped Kuiper belt. It is the home of Pluto and several other dwarf planets. The entire Trans-Neptunian region is largely unexplored and composed mainly of rock and ice. Sometimes, Trans-Neptunian region is described as the third zone of the solar system, enclosing the inner and the outer solar system. Trans-Neptunian objects are any solar system minor planet that orbits the Sun at a greater average distance than Neptune. The first trans-Neptunian object to be discovered was Pluto in the year 1930. The most massive TNO known is Eris, followed by Pluto, Haumea, Makemake, and Gong. As of July 2014, over 1,500 trans-Neptunian objects have been catalogued. The Kuiper belt. The Kuiper belt is a great ring of debris similar to the asteroid. It consists mainly of ice objects. It's a region beyond the orbit of Neptune at 30 astronomical units to about 50 AU from the Sun. It contains thousands of dwarf planets. The Kuiper belt is much larger than the asteroid belt. It is wider and massive than asteroid belt. The picture to the right shows largest known trans-Neptunian objects. Kuiper belt objects are more than 100,000 that have a diameter greater than 50 kilometers. Many Kuiper belt objects have multiple satellites. Most have orbits that take them outside the plane of the ecliptic. KBOs are composed of rock and metal, like the asteroids, but they are also frozen ices like ammonia, methane, and water. TNOs are KBOs, but KBOs are not TNOs because the distance range of KBOs from the Sun is much farther out in the solar system. Kepler's laws of planetary motion. The Kepler's laws of planetary motion describe the orbits of objects about the Sun. It states that each object travels along an ellipse with the Sun at one focus. On an elliptical orbit, a body's distance from the Sun varies over the course of its year. The positions of the bodies in the solar system can be predicted using numerical models. Effects of Sun's gravity. Objects that are closer to the Sun with smaller semi-major axes travel more quickly because they are more affected by the Sun's gravity. The orbits of the planets are nearly circular, but many comets, asteroids, and Kuiper belt objects follow highly elliptical orbits. Perihelion and aphelion. A body's closest approach to the Sun is called its perihelion, whereas its most distant point from the Sun is called its aphelion. This picture shows planets of the solar system. The closer the planets are to the Sun, the faster they travel. For more information, contact Astronautics for Exploit. Thank you.